Sadeh. I'm the tech lead for the storage and data team at Emerging Technologies. And the title is a bit clickbaity, but I really want to present OCSN, which is the Overlay Cloud Storage Network project I've been working on recently. And unlike the earlier talk, is really in its initial stages. So first, I'm going to go over the motivation for why OCSN, and then I'm going to go over OCSN in the short demo. So I have a history with open source goes back a couple of decades. Was one of the first contributors to Ceph, and I was extremely lucky to see how that small project grew from really tiny code base into successfully adopted project with mainstream outreach. So I also saw the evolution of RESTful object storage. In 2009, I started the RGW project, which was among the first solutions to adopt the AWS S3 API. But ever since, there has been many similar projects and other solutions that can be deployed in many different environments, such as public and private cloud, and also its local endpoints servicing local applications. Organizations and users can store data in different locations on different service providers. Services can be selected based on various factors, such as performance, cost per size, cost per transaction, data redundancy, location constraints. That can be due to regulatory requirements. There's, depending on the API support, integration with other cloud systems, and organizational policies, and many other reasons why. Now, these requirements and parameters may change over time. So it's not a static environment, and there can always be need to replicate data or migrate it. Now, data replication can be happening due to many reasons. One is regular operation of the system. For example, data that's generated by autonomous vehicle might need to be uploaded to the manufacturer's data center in order to be used there for machine learning or post-processing or something. Other use cases can be data migration, disaster recovery, edge to core, content distribution, and many other reasons. So I want to go over these use cases quickly. So, or some of the use cases. Says there can be a complete site disaster recovery where all the data is just mirrored to a different site. There can be a targeted replication of subset of the data. There is an active use case where there are multiple regions, and they each allow access to local users, and then the data is being synchronized between the regions. So the users are accessing same data basically, or sharing the data between them, but they each access different region. Content distribution, as I mentioned earlier, for example, video streaming, which allows accessing data locally at the regions. And edge to core is another one. Application that is local at the edge may write data to a local service, could be local service on an edge device. And then when conditions permit, it can upload the data upstream to core, or can actually also fetch data from core when needed. Another aspect to consider is data policies. For example, healthcare data in the US should not be sent outside of the US. So that's another parameter. Now, these use cases are not all in isolation necessarily. So there can be a mix of them that generate a complex topology, and which is hard to control and manage. Basically, some kind of a complex network of object storage systems with different data flow between them. Some service providers have a mechanism to automatically transfer data between the services, or between the regions, or between the entities. So this allows for use cases like geographical replication. However, these usually do not cross the service boundary. So AWS would not have inherent option to upload everything to Azure, for example. Now, the ability to transition operation between providers can provide better service resiliency and or help organizations manage the service costs, comply with required regulations, and though some solutions do provide a way to upload or migrate data, but these are usually not like a private installation, such as SafeRGW. Now, this is data migration in itself and replication is only one part of the issue. The other part is how the applications need to respond to the data movement, basically. If data is served from a different provider or from a different region, the application needs to be adjusted in order for it to be able to reach it. So there are like different endpoints, different credentials, different user. Even if it's within the same service, the name of the bucket that's been used. Now, a system where the application can react transparently to those changes is important. There is a subset of solutions that provide some kind of a method to bridge this gap, which are, like, for example, the multi-cloud gateway. It creates a virtual representation of the data network, and it hides all the details behind it. However, these solutions inherently have scalability issues. The API support depends on whatever they support, and it can be a single point of failure. So to sum up, the interoperability between the services is lacking. Organizations are left with either accepting the vendor lock-in, or they need to build new ad hoc solution. And control of these systems can get really complicated, managing and controlling it. So, introducing OCSM. Now, the overall cloud storage network is designed to deal with these issues. It creates a virtual network of storage providers, similar to how OVN works with actual networks. The OCSN is made of storage providers, their users and their data, so they are all entities within the OCSN, and also data replication entities. The OCSN manager is responsible for creating this one virtual storage system that can be comprised by multiple distinct storage providers. It enables dynamic services by defining the mechanisms that allow for multiple storage systems to be used together in a virtual single logical system, and defines higher level requirements for such system to exist. It manages its structure and provides its operational control interface. So for the user and applications, it provides the information that's needed for them to access the service data. For the admin, it provides the ability to set granular policies about how data can be distributed or how it can be accessed. And it also deals with orchestration and provides the information that is needed for orchestration services to form and control the structure of the system and to ensure its correct operation. OCSN defines an entity called virtual bucket, which is a set of buckets that can exist across different services and all act as one virtual bucket. So the idea is that if we have a bucket on AWS and a bucket on Ceph that we want to share the data between them, we'll have a virtual bucket. And then the application could reference that virtual bucket instead of referencing directly the physical location of where the data is, either at Ceph or AWS in this case. Now, there can be policies that can be set on these virtual buckets. And for example, can say that a virtual bucket the data can only reside in the US or different other options. The OCSN manager is, as I mentioned earlier, is the entity that controls and manages the system configuration. It stores the state of the structure, the system structure. It provides the interface to the different entities. Applications access the services for data directly, and that's an important piece of information. They don't go through a proxy or a gateway in order to access the data. So the applications get the information for where to access the data from the OCSN manager, and then they go to the services themselves to fetch the data or to write the data to. The OCSN manager allows defining the logical connections between all the buckets that are needed to exist in order to facilitate the data replication. And it also provides interface to orchestration systems and provides them with the required data needed in order for them to deploy the needed services and or the needed configuration. I mentioned the data policy on the virtual bucket, but it can also be set on at different levels, at the organization level, at the group level, at the user level, and it can set rules on the service use, on the data replication, on the access control, basically covering all the options. It keeps track, the OCSN manager keeps track of the deployment. And it interfaces with the different entities. And that way it can know whether the system is functioning correctly according to what the admins want it to look like and according to what the users have said, or whether there are issues. And then it can trigger orchestration operations, or can provide information to the orchestration that would allow it to then fix itself, or raise a flag and say the system is not functioning. It is designed to be dynamic so that if there are changes, it can adapt to. So it can adapt to policy configuration and setting changes. It can also, for example, an organization can decide that from now on it's going to use Azure instead of AWS. So it would provide the information to the orchestration and to the admins about how the system needs to be adapted if it needs to, but also would now make sure that the application would access the correct entity, the correct endpoint, and would provide them with the credentials and all the information about that. OCSN is designed to be modular and to allow different entities to be plugged in, so that it's not a monolithic set of software. It has different modules. For example, a module that allows it to deploy Ceph, a module that allows it to create data on AWS, Azure, and whatever is created is needed in order there for it. But also there are modules for credentials management and modules for policy management. And now I have a demo. I'm not gonna be brave and like Eric earlier and try a live one, but I recorded one earlier. And let's take a look. Oop. Let's try to restart it. So before I show it, I'll give a bit of background about the demo. So let's say we have a photo sharing application that is backed by object storage. Initially, the application keeps everything on Ceph. Then we want to move it to AWS. So the demo will show how OCSN is being used in order to facilitate that. We'll demonstrate the dynamic transition and how OCSN reports deployment issues. So the first step would be to orchestrate deploy Ceph, and the orchestration module would update the OCSN manager about the deployment status. So let's do that. So it'll take a minute. And so as I mentioned It's gonna basically deploy Ceph from scratch, set up the Ceph RGW multi-site zone, create credentials for users to access, create a bucket, and then update the CSN manager with information about all the entities that were created. Give it a few more seconds. I can take a look at that. That's kind of how the flow is here. So a user has been created. And we have everything running. We'll look at the service list on OCSN. And we have one service. It is a local service. It has a local endpoint. Okay, the next step would be to start before that, we're going to load we're going to look at the virtual bucket that was created. We have one bucket instance associated with this virtual bucket. And now we're going to load the credentials. And the bucket is empty. Let's see, we have one bucket. Well, the next step would be to actually start the application. Let's see. So the application communicates with the OCSN manager in order to fetch the information about the virtual bucket that exists, and that's how it knows where to connect. So we're basically going to start it. Now, we don't feed it the credentials directly. It goes to the OCSN manager and gets it from there. We're going to log into the application. No photos. It mentioned, but we can see that it's served by our local endpoint. Yep.
Pause that for a second. Any way you can share that? I think the online folks are not able to see that. They see your presentation.
Sure. Okay, I'll continue. All right, so now we are uploading an image. And we have an image on our local Ceph object storage, Ceph RGW. Okay, so now everything works fine. We want to transition to AWS. And AWS orchestrator basically creates a bucket on AWS and registers it with the OCSN. It created, so now our virtual bucket will consist of two buckets, one on RGW and one on AWS. Let's see. Yeah, so same virtual bucket, but now it has two bucket instances. One backed by AWS on US East 1, and one backed by our local RGW service. And as I mentioned, we have two services now. One is AWS, one RGW. The next step, we're going to check with the OCSN about the data flow. So we run the flow verify command, and we see we have an issue. We have no data flow between the two services. It identified that it needs to have the data flow because our virtual buckets are set. Our virtual bucket is set to replicate the data between those two services. So there's no data flow in both directions, not from RGW to AWS and not from AWS to RGW on the specific buckets that were created. But we're stubborn and we'll force the policy on the virtual bucket to go to AWS anyway. Let's see what happens. Well, to start with, the application now uses AWS as the backend. We can see it, reports about it, but there's no data, which is expected because we didn't set data migration or data replication in this case. So we'll start the orchestration module that syncs data between RGW to AWS, and that's based on the RGW Cloud Sync feature. It'll take a minute because it really starts a whole new Ceph cluster in this case that you leverage it to the Ceph multi-site for data sync. Okay, it did it. And now we're going to check the data flow with the OCSN manager, and it improved somewhat. We do have data flowing from RGW to AWS. We don't have it in the reverse direction. Let's take a look at the application, and voila, the data showed up. Yep, so that's the demo. I can go back to the slides now. Just a second. And yeah, we can go over it once again. So basically, the once we started AWS, the orchestration, or they created the AWS bucket, the orchestration module updated the OCSN manager, and the photo app now was set to access the bucket on AWS. However, we still haven't set any sync from RGW to AWS. Now, since the OCSN manager is supposed to be dynamic and modular, we could have had a module that would start the the sync automatically, but this is not really implemented yet. But we do have the option to know what's missing and what's not working. So the LCSN manager allows us to know about that problem. The Cloud Sync module, once it started, the orchestration notified the LCSN manager about the new status. Of course, the data only flows from RGW to AWS in this case, but the photo application can now function correctly as long as it stays on AWS. Right, that was the demo. That was the presentation. Any questions?
Hi, thanks for that demo. You had talked earlier about like having policies, like I think your example is, data can't cross country boundaries or things like that. Does that kind of stuff integrate with something like an open policy agent?
It could, right? So it's supposed to be modular, so you'd have a module that would let open policy to do that, right? So the idea is for creating a system that is modular and adaptable, so to different systems, not necessarily one technology or another. Yep.
So how would this integrate with access control? How do you ensure secure transfers, and how do you integrate with different access control mechanisms?
So the LCSN manager would be plugged into different access control mechanisms, right? So the manager itself is what's supposed to be providing the credentials to the application, but it has an API and interface that would allow it to create a module that would integrate with external access control systems.
Assist any of the credentials?
Not necessarily.
No. But that could be a sort of point with security guys.
Yeah. Anything else?
Any other questions?
Maybe.
Oh, sorry, I was a bit late. Thank you. What all cloud platforms does this support? Is it pretty much all the major clouds, or do you guys have a roadmap?
Well, it's the beginning in my talk. It's really in its infancy. So right now, it's more of where we're going to. So yes, it's gonna support different clouds, but that would require creating the modules for those.
Okay.
Anything else? We have. All right.
Thank you.
Thank you very much.